Our moon is drifting away from Earth, inching farther and farther away at a rate of 3.8 centimeters or 1.5 inches per year. Now, this might seem like an inconsequential amount of space, especially given that the moon is around 384,400 kilometers from Earth. But over the course of a few million years, this small distance adds up to some pretty significant changes. So what exactly is causing the moon to drift away? How fast is it actually moving away? And how will this affect the Earth and the people living on it in the future? To better understand the mystery of the moon's movement, we need to travel back in time to when the moon first formed. And we are not talking about the origin of the moon myth, where it is said that the moon was born out of a giant fish. We are talking about the scientific theory supported by evidence that the moon formed from debris ejected from the Earth after a Mars-sized planet crashed into it. So let's go back to the days when the Earth and the moon were brand new, hot balls of rock orbiting close to each other. In those days, the moon was about 10 to 15 times larger in the sky than it is now, which would have been quite the sight to behold. But as the millennia passed, the moon began to spiral farther and farther away. One of the most accepted theories among astronomers is that this outward motion was caused by the gravitational force of the tides. The moon's gravity has always pulled on Earth's oceans, creating bulges of water on the side of the Earth closest to the moon and on the opposite side as well. These bulges, known as tidal bulges, are slightly larger on the side facing the moon due to the direct gravitational pull. However, Earth's rotation causes the tidal bulges to get slightly ahead of the moon itself. As the Earth spins towards the east, the tidal bulge on the right side moves faster than the moon, which stays in a fixed position relative to the Earth. Now, this difference in speed might seem insignificant, but over millions of years, it has a big effect on the Earth and the moon. The tidal bulge on the Earth's right side pulls the moon slightly forward in its orbit. Imagine being pushed by an invisible hand, always keeping the moon one step ahead of the Earth. This gentle nudge speeds up the moon, raising its orbit a little higher. And as the moon climbs higher and higher in the sky, it moves away from the Earth, centimeter by centimeter. But this celestial push and pull isn't a one-way street. The moon also exerts a force on the Earth's rotation. Remember those tidal bulges we talked about? They're not just sitting ducks, they have weight, a lot of weight. As the moon's gravity tugs on these bulges, it slows the Earth's rotation. This means that the Earth doesn't spin as fast as it used to. In fact, 620 million years ago, a day on Earth was only 21 hours long. Now it's 24 hours. And if you look closely at the moon, you can see that it's moving away from the Earth. But how far exactly is it moving away? Is it drifting at a constant speed? These questions lead us to another incredible innovation by NASA: laser ranging experiments. These experiments involve shooting lasers at mirrors left by astronauts on the moon during the Apollo missions. By measuring the time it takes for the laser beams to bounce back, scientists can calculate the distance between the Earth and the moon down to the millionth of a second. Using this method, scientists found that the moon is moving away at an average speed of 3.8 centimeters or 1.5 inches per year. This distance might seem minuscule, but it's enough to show that the moon is slowly but steadily moving away from the Earth. So when will this slow and steady movement cause noticeable changes on the Earth? Will it have any effect on our daily lives in the future? Well, it turns out that the moon's journey away from the Earth is not just a passive process. It's an active one. The moon is not just being pushed forward. It's actively pulling itself away by changing its own shape. You see, the moon is not a perfect sphere. It's slightly wider at the equator than at the poles. This equatorial bulge is caused by the centrifugal force created by the moon's rotation. As the moon rotates on its axis, the centrifugal force pulls material from the poles to the equator, making the moon a bit wider. And guess what? The moon is rotating faster now than it was millions of years ago. That is because the tidal forces from the Earth are not only pushing the moon forward in its orbit, but they're also speeding up its rotation. Now, this increase in rotational speed might seem insignificant, but it's enough to change the shape of the moon and move it away from the Earth. In fact, scientists estimate that the moon will continue to move away at a rate of 3.8 centimeters per year until it reaches a point called orbital resonance with the Earth. At this point, the gravitational forces between the two planets will be perfectly balanced, and the moon will stop moving away. And when that happens, the Earth and the moon will be tidally locked, meaning that the same side of the moon will always face the Earth, and the same side of the Earth will face the moon. This won't happen for millions of years, though. At the current rate of movement, the moon will have to drift away by about 100,000 kilometers before it reaches orbital resonance with the Earth. But when it does, it will be a significant event in Earth's history, marking a new stage in the relationship between the two celestial bodies. As we continue to learn more about the moon and its effects on our planet, we realize that it is not just a static object in our sky, but a dynamic partner in a cosmic dance that has been going on for billions of years. The moon's slow drift away from Earth is a testament to the intricate balance that makes life on our planet possible. From the tides to the length of our days to the stability of our climate, the moon plays a vital role in maintaining the conditions that allow life to thrive. As we gaze up at the moon and appreciate its beauty, we should also remember that it is a silent partner that has been with us since the dawn of time, silently shaping our planet and our lives in ways that we are only just beginning to understand. Now, you might be wondering, what if the moon suddenly vanished? How would that affect our world? Well, it wouldn't take long for our planet to feel the absence of its celestial partner. Without the moon's gravitational pull, tides would disappear altogether. Marine ecosystems that depend on the tides would collapse. The Earth's rotation would speed up, shortening our days and disrupting our sleep cycles. And our climate would descend into chaos, with extreme weather events and unpredictable seasons. The moon's presence has a profound impact on our planet, and its removal would have catastrophic consequences. In conclusion, the moon's slow drift away from the Earth is a reminder of the dynamic nature of our universe. It's a celestial dance that has been unfolding for billions of years, shaping our planet and our lives in ways that we are only just beginning to understand. As we continue to explore the mysteries of the cosmos, we can appreciate the beauty and complexity of the universe and our place within it. So the next time you look up at the moon, remember that it's not just a static object in our sky. It's a dynamic partner in a cosmic dance that has been unfolding for billions of years. And as we continue to learn more about the moon and its effects on our planet, we can appreciate the delicate balance that makes life on Earth possible. If you found this video informative and enjoyed learning more about the moon's journey away from the Earth, please don't forget to hit the like button and subscribe for more updates.